Hi, welcome to myprojectbazaar.com. This video will lead us to the demo of privacy preserving multi-keyword ranked search over encrypted cloud data. With the advent of cloud computing, data owners are motivated to outsource their complex data management systems from local sites to the commercial public cloud for great flexibility and economic savings. But for protecting data privacy, sensitive data have to be encrypted before outsourcing, which obsoletes traditional data utilization based on plain text keyword search. Thus, enabling an encrypted cloud data search service is of paramount importance. Considering the large number of data users and documents in the cloud, it is necessary to allow multiple keywords in the search request and return documents in the order of their relevance to these keywords. Related works on searchable encryption focus on multiple keyword search or Boolean keyword search and rarely sort the search results. The challenging problem of privacy preserving multi-keyword ranked search over encrypted data in cloud computing. A set of strict privacy requirements for such a secure cloud data utilization system. Among various multi-keyword semantics, the efficient similarity measure of coordinate matching, that is, as many matches as possible to capture the relevance of data documents to the search query. Inner product similarity is to quantitatively evaluate such similarity measure. The basic idea for the MRSC based on the secure inner product computation and then give two significantly improved MRSC schemes to achieve various stringent privacy requirements in two different threat models. To improve search experience of the data search service, we further extend these two schemes to support more search semantics. Through analysis investigating privacy and efficiency guarantees of proposed schemes is given. Experiments on the real-world data set further show proposed schemes indeed introduce low overhead on computation and communication. First of all, this project has three members. They are data owner, client and cloud service provider. The data owner first of all selects the data. This data may be a book data set. For this data set, the data owner have to create the index. This index is in the form of binary, and then this index is encrypted by using a cryptographic algorithm. Again, the raw data, that is the data set, is encrypted by using the symmetric algorithm. And then this encrypted data and then the encrypted index, that is in the binary data, that is to be encrypted, and then both these data are transferred to the cloud. The cloud contains data and then index in the encrypted format, and then the cloud consumer is the third one. The cloud consumer selects some of the request and then send the query to that cloud server, and then in cloud server the coordinate matching is happen. For this coordinate matching, the query of the client is encrypted by using the binary format. In that binary we can find out which data is matched to that client request. Using that, the original data, that is the encrypted data from the server, is transferred to the client. This is called as a ranked search. This ranked search result is sent to the client. Now the data in the client is in the encrypted format. The client gets the access control from the data owner. Then only the data owner send the decryption key for that data, and then the client can decrypt the data by using the key that is received from the client, key that is received from the data owner. Let us see the demo of privacy preserving multi-keyword ranked search over encrypted cloud data. Now press enter. Now select the dataset. This dataset contains the book name, publisher name, publishing year, and then author name. Now press view. This is the content in the dataset. Now press next. Now the bit vector is generated for the book title. This is the bit vector of the data. For each data, the bit vector is generated, and then the binary data is also generated for a book title. This is the binary data for the book title, and then the bit vector is generated for the author name. Likewise, binary data is also generated for the author name. Here it is the binary data for the author name, and then press next. Now the bit vector is generated for the publisher name, and then the binary data is also generated for the publisher name. Now the bit vector is generated for the years, and then the binary data is also generated for the years in the data set. Now press next. Now click the original data. Now the original data is displayed to the data owner, and then the data owner have to enter the 16-bit key for encryption, and then press data cipher. Now the data is encrypted, and press next. Now click the original index. This original index is the binary data of the dataset. For this also, the data owner have to enter the 16 bytes key and then press index cipher. Now the binary index are encrypted by using the advanced encryption standard algorithm, and then now the data owner have to upload the data to the cloud. For that, run server.java. Now press secure data and click the upload data button. Now the data is uploaded. Now the data is received in the server side, and press secure index and click the upload index. Now the data is uploaded, and the index is received in the data service provider side. Now press next. Now the service provider is ready to get the query from the client. Now run the client.java. Now the client have to get the access control from the data owner, so that the client have to enter the details. First of all, the client have to enter the username, and then select the date, and select whether the user is technical employee or non-technical employee, and select the designation, and press select experience. In that you have to select the experience of the candidate, and then this detail is sent to the data owner. Now press next. Now this is the data owner. Now press receive. The data owner receive the client details, and then press get key. Now this key is transferred to the client. Now press next. Here the data user have to enter the queries. For that, select the book name, and then select any one of the book name from this list and press search, and then select author. Now here the user have to select any one of the author name and press search. Now press next. Now the publisher name is also a input for the client, and press search. Now press here. Now the client also enter the year. Now press search and press send. Now this data is ready to send to the service provider. Now press receive. Now the query from the data user is received by the service provider. Now press bit vector. Now the bit vector is generated for the query from the client, and then press next. Now for that bit vector, the binary data is generated, and then the service provider ciphers the binary data, and then press next. Here the index searching is going on. Here these are the indexes that matched with that query from the client, and then data searching. These are the data that is relevant to the user's query. Now press send. Now press next. Now click the receive button. Now the encrypted relevant data are received to the client. These are in the rank order wise, and then the client have to get the key from the data owner. For that, press the transfer key and then click get. Now the key is received to the client. Now press decrypt. Now the relevant data are decrypted and displayed to the client. These are the relevant data for the client.